Bismillahirrahmanirrahim. I hope you will be all right. And today we will discuss about the density functional theory and wien2k and how to initialize wien2k and how to run wien2k. आज हम इसमें briefly discuss करेंगे कि wien2k इस्तेमाल करते हुए आप कैसे जो है वो स्ट्रक्चर जनरेट कर सकते हैं, कर्व्स ड्रा कर सकते हैं, ऑप्टिमाइजेशन कर सकते हैं या SCF जो है वो ड्रा कर सकते हैं. Today we will learn about the how you can generate structure with the help of wien2k and how you can gain curve from wien2k and how you can optimize values and how you to calculate band gap and SCF. Let's start. First of all, you have to create directory. Directory mean what you want to calculate. आप सबसे पहले यहाँ पे डायरेक्टरी कैलकुलेट बनाएंगे कि डायरेक्टरी मीन कि आप किसी भी एलिमेंट की प्रॉपर्टीज़ जो फाइंड करना चाहते हैं, उसका स्ट्रक्चर जनरेट करना चाहते हैं, उस नाम से यहाँ पे आपने क्या करना है, डायरेक्टरी जनरेट कर देनी है. जैसा कि यहाँ पे लिखा हुआ है कि आपने अपना नाम लिखना है पहले NaCl. हम यहाँ पे क्या करने जा रहे हैं, NaCl की प्रॉपर्टीज़ कैलकुलेट करने जा रहे हैं. तो यहाँ पे आपने NaCl टेस्ट वगैरह लिख देना है और आगे आपका काम जो है वो स्टार्ट हो जाएगा. अच्छा, यहाँ पे आपने टाइटल पे आ जाना है. टाइटल पे आप लिखें या ना लिखें इससे कोई फ़र्क नहीं पड़ता. देन वी हैव टू use lattice parameter. We are using sodium chloride and the lattice parameter of sodium are 225 FM and 3M. ठीक है, means you have to select the lattice space group. ठीक है, space group of NaCl means sodium chloride is 225 FMCl and you can select here 225 FM3M. Then you have to choose lattice parameter. Lattice parameter of sodium chloride is 5.460176780 and you have to put these value in A, B, C and these blocks. If you have other elements like molybdenum disulfide, then the lattice parameter will be changed and the lattice parameter are changed according to your element. Then we have to put the values of angles alpha, beta and gamma. Because sodium chloride structure is cubic, because structure of sodium chloride is cubic, so the angles among the lattice parameter are 90. Alpha will be 90, beta will be 90 and gamma will be 90. And there are two atoms in sodium chloride. One is sodium and other is chloride. You can put first sodium and give its RMT. Roots mean muffin radius value is known as RMT, and you should be know that what is RMT, and then you have to put the value of RMT in this column. Then you should have to know the positions of atoms X, Y and Z, and position of sodium is 0, 0 along x-axis, y-axis and z-axis, while position of chlorine is 0.5, 0.5 and 0.5 among the x, y and z. So then you have to click edit structure file and then you will click on save structure. If you want to change RMT value, then yeah, or you have to select automatically RMT and continue editing, where you put the value of RMT, and this will change the actual value in your previous structure here. Okay, if you put exact value here to, then you do not need to set automatically RMT and continue editing. You can just click on save file and clean up. Okay, and step structure. After that, by putting the values, you can see your structure. Is your values are correct or false? This will described by your structure generation. Yes, our value is absolutely right. We can see from this structure, this is the structure of sodium chloride, and the structure tell us that our measured and calculated value that we put in the previous options are very true. So we can examine this structure briefly by clicking display y coordinates, and by clicking x y, we can see this structure along x, y and z on any axis. Okay, if you want to draw atomic symbol, then you click display, then click atomic symbols. You can see that sodium chloride atomic structure, atomic symbol. Okay, or if you want to see crystal cell, then click here. If you want to unicolor bond, click here. In display, there are many options you can choose according to your desire. Winger shields you can draw also, and remove them. Molecular surface, this is the molecular surface of sodium chloride, and it can be removed by again clicking. Perspective projection can also be drawn. This is perspective projection. Depth curing, this is depth curing. If you want to anti-aliasing, then click here, display, and anti-alias. Okay, you can change your structure, position of NaCl, interchange, and ball as, space as, primitive cell mode, this is primitive cell mode, and conventional cell mode, and this is conventional cell mode. You can remove them by clicking again. Okay, I think you can understand this very well. Okay, lighting on, lighting off, they are also available. Okay, by lighting on off, you can off lights and you can on lights. there are different structures, positions you can see here, understand? And then off light. This is the structure of sodium chloride. After that, we can run our SCF cycle. For this, we have to initialize our calculations. First of all, you have to put VXC option, or what you want to calculate with the help of PBE, LDA, WC, or PBE solved or default. If you want to calculate these initial calculation with GGA, then you have to put the value of default 13, and then you will put the energy separation between core and valence shell. The energy separation between core and valence shell in sodium chloride is -6, and it is changed for other elements. Then you have to put RK max. This is 9 for sodium chloride, and if you use other element, then the value of RK max will be changed. Then using K point, actually there are 1000 K points, but according to our structure we will use 3000 K points. Check batch values, okay. Run initialize view ST out, and we have to check all these values, access and execute. There are two number of items, so there we will put 2 and this execute, and initialize lab W, continue. Then we will move on the another step, view optimum. Then we have to click save and initialize. Then we will check all these steps one by one, and because sodium chloride is simple structure, so we just click them and execute them. There is no need to modify or change any value. Click here and go next step, save and initial. This use structure file generated. If you want to use your structure file generated, then click yes. If you want your previous file you have generated or created for structure generation, you can click yes, otherwise no. Copy structure file, save initialization. Alternatively, we have energy value is -6 for sodium chloride, so we will click execute and initialize. We output, save, and then we will move towards next step and save and initialize, check, save and initialize, prepare input file, XK generation. Here we have to put K points. K points for sodium chloride is 11 cross 11 cross 11. This is K mesh. You have to know by this. Here you put will 0. These 11 cross 11 cross 11 is for sodium chloride, and if you use other elements, this value will be changed. First of all, you have to study the literature review about your element. Then you should use wien2k, execute, and there are 11 cross 11 cross 11 mesh. This means our mesh is true, and initialize calculation. Okay, and view k list. This is also true, and then X start and initialize. Click here save. Perform spin polarize because structure of sodium chloride is parallel, so we do not need to spin polarize. So we will click on no and continue with run SCF. You and save calculation is and save. Okay. After that, when you observe all the calculations and when you check all these points and block, and after observing that all value are true, then you will click continue with run SCF. Here when you will click, then your SCF will be run. Okay. If you want to save calculation, click here. If you want to remove, click here. Because I already done this calculation, therefore I will delete it. Okay. Delete this file. So because you did not do it before, so you should have to click save calculation with okay. I hope you can understand how you can run wien2k and how you can create structure, view structure generation, and how you can run SCF cycle. By following these steps, you can easily check your structure generation, initialize calculation, and you can run SCF. For more informative video about wien2k, you should follow our channel. Please subscribe our channel, and in next video we will discuss about how to optimize our calculation and how can we draw our graph. Stay blessed, stay happy. Okay, Allah Hafiz.